Hello, dear guys. Today we're going to discuss spermatogenesis and oogenesis. And my name is Knyazhev Igor. I'm a teacher of histology in Solendok University. So we're going to discuss about germ cells. Major germ cells are also termed as gametes, and you heard about it in biology classes in your school. And there are male gametes, also named as sperm cells or spermatozoa, and female gametes are also known as oocytes or egg cells. And fusion of these gametes, of course, causing the formation of zygote, which is and this process is named as fertilization. And this is our further topic. And of course, also you heard about it. The gametes composed of 23 chromosomes, and together, after the fusion, after the fertilization, it will form the 46 chromosome zygote. It's a new life is formed by this. The reduction of the number of chromosomes and the recombination of the genetic material are processes, both of which occur during meiosis, that we discussed in last class. And meiosis is a special form of cell division that only takes place in gametogenesis. It takes place in reproductive organs. In males it's testes, in females it's ovary. Gametogenesis mainly describes how the oocytes and the ovary and the spermatozoid and testicles are generated during the period of human sexual maturity. So that's understandable. We discussed it in previous class. The male gametes are produced in large numbers in the testicles from puberty onwards, and for the rest of the man's life. Several million of them are present in a typical ejaculate. Now let's see this diagram. Spermatozoa and the epididymis. So this is almost natured spermatozoa. They are present in a crowd in epididymis. It's part of testis, part of testicle. Number 2 is a tail of the sperm cell, and number 3 is the epithelium of epididymal duct. They are final maturation of spermatozoa happening here. But before, we need to discuss what happened before the formation of spermatozoa. So before they are passing through the epididymis. So that will be elaborated later. Now, a few words about female gametes, oocytes. They are already generated and stored during the embryonic and fetal periods, and certain numbers of them, 1 to 2 million, are present in both ovaries when a baby girl is born. So again, this laying of these gametes are happening in ovaries before the birth, 1 to 2 million of them. It's constantly diminishing up to menopause. So gradually the cells are dying by the process known as apoptosis. So that's this process is going constantly, and approximately only 400 oocytes finishing their maturation. So, but 1 to 2 millions gradually apoptosed, they died. Approximately 13 periods in 30 years, so we can calculate it is 400 oocytes. Hormonal regulation operating in cycles is responsible for the maturing and expulsion of the oocytes from the follicles. And this process we also going to discuss a little later. This is the typical structure of oocyte. Oocyte is present here, this is oocyte, and surrounded by follicular cells. So they are supporting cells. This is oocyte. Around we have a zone pellucida, so pellucid zone, and around we have follicular cells. And in the future they will also form the corona radiata. These follicular cells are the corona radiata cells. Okay, and details. So if you confused in something, so don't worry. So we will discuss it in details a little later. Now let's talk about seminiferous tubules. So every testicle, it composed of these seminiferous tubules. They are tough. These tubules, so it is cross section of it, but actually it's a tubule, and very toughly they are forming the testicle. And let's continue. So this is typical seminiferous tubule, and in structure we can see the Sertoli cells. Sertoli cells are the large cells between which maturation of the sperm cells are going on. Along with the Sertoli cells, between the Sertoli cells, we have a few maturation steps of the spermatozoa. So in details, again, we'll discuss it a little later. And in the basal compartment of this seminiferous tubule, we have a spermatogonia, so unnatured sperm cell. So and later, gradually by maturation, with the process of meiosis, form the sperm cell. Finally, sperm cell, so which is able for fertilization. Around we have myofibroblasts, we have some media cells which are not important for us right now. So spermatogenesis. Spermatogenesis is the entire process of maturation of sperm cells. It's initiated in the male testes with the beginning of puberty. Before puberty, spermatogenesis is not happening. Before puberty, we have no sperm. We don't have testosterone, and this testosterone is not stimulating the spermatogonia to be split. And spermatogenesis is controlled by SRY gene. SRY is it's gene which is present in Y chromosome, which is present only in males, yeah, in humans with the male phenotype. So that's SRY gene, and it predisposes the formation of male genital system development. Okay, so here you can read this information. It's like observation information. The development of the germ cells begins with the spermatogonia at the periphery of the seminal canal and advances towards the lumen over spermatocytes 1, then spermatocytes 2, or secondary spermatocytes, and finally we have spermatids, which are expulsed into the seminiferous tubule, and finally spermatids are forming mature sperm cells. Let's talk about it. So stages of spermatogenesis are A spermatogonium, B spermatogonium, primary spermatocyte, secondary spermatocyte, spermatid, and sperm cell. It's not compulsory to learn by heart. It's important to understand it. Take a look what is going on. Approximately 64 days cycle of the spermatogenesis can be subdivided into 4 phases that last different lengths of time. So again, for 64 days we need to entire cycle from spermatogonia towards the sperm cell, and this might be heard about this when males are preparing for the fertilization. They have to avoid drugs, alcohol, cigarette smoking for 64 days, and then all the sperm cells will be renewed. So in these stages are mitosis of spermatogonia, this spermatogonia A, mitosis up to the primary spermatocytes. It takes for 16 days. 16 days. Then first meiosis, so it's a division of primary spermatocyte into the secondary spermatocyte. So again, you see, primary spermatocyte, it's a diploid cell, and secondary spermatocyte is haploid cell. It takes 24 days. And then second meiosis, just in few hours, it's forming the spermatids. And finally, maturation of the sperm cells from the spermatid to sperm cells. It takes 24 days. And you can mention this mitosis 16 days, and first meiosis 24 days, and spermatogenesis 24 days. Second meiosis is like just a few hours. And that's why we care about this and these stages, especially where mistakes might happen. This typical picture, spermatogonia A, it divides by mitosis with the 16 days and forming another spermatogonia A to maintain the population of spermatogonia cell population, and spermatogonia B, which undergoes the process of other mitotic divisions and forming, in the end, forming the spermatocyte. And you see, we're running out, and spermatogonia B will never recover back to the spermatogonia A. All spermatogonia A producing by mitosis, another spermatogonia A. It's a normal sequence. And that's why population of spermatogonia A is maintained by this mitotic division. But every cell which undergo the process to form spermatogonia B finish their maturation in a formation of spermatocyte. So here it's shown that it's 8 spermatocytes are formed, but actually in reality it differs. From person to person it differs. Some of them 8, some of them 16, some of them 4 are formed. So, but main point is this junction between the cells. It's not imaginary junction, it's real junction. The cells are interrelated to each other. They have a common cytoplasm, but with a different nucleuses. So that's you can say that so final stage of interkinesis, which is named here, between the cell divisions, process goes incompletely because we don't have cytokinesis, so we don't have division of cytoplasms till the end. And finally, and even spermatocyte 1, which is diploid cell, so it converts into the spermatocyte 2 by the process of meiosis, and forming forming spermatocyte type 2, and then second meiotic division finished in the formation of spermatids. Spermatids, so you see, if here we have 8 cells, just imagine, so here we multiply it 4 times, 4 multiplied with the 8, it's how much is it? It's 32, so must be from 8, so from 1 spermatogonia B we produce, so from 1 spermatogonia B we can produce 32 sperm cells, so that's should be imagined. And you see, we have an absolutely equal sperm cells formation in the end. So, and process which is named from the spermatogonia A till the spermatid formation, it's named spermatocytogenesis. And the further process of maturation of spermatid into the sperm cell, it is named as spermiogenesis. Spermiogenesis. So that's I want you to point it out and remember. Okay, among the spermatogonia, in all, over 1 billion of those testicles that form the basal layer of the germinal epithelium. Serotypes can be distinguished, type A and type B. Okay, actually we discussed it, and we can see it by the light microscope. Only secondary spermatocyte, so primary spermatocytes are visible because it's lasting for a lot of time. So 24 days we need for their meiotic process, for the first meiotic process. But second meiosis happens in a few hours. That's why if we do the histological examination, we hardly can see the secondary spermatocyte. We will see the spermatid in the process of spermiogenesis. So, in 24 days can be divided into 5 sections: leptotin, zygotin, paketin, diplotin, dikinesis. It's a prophase of first meiotic division. Again, I repeated, it's primary spermatocyte toward the secondary spermatocyte maturation. So these stages you also very confident in. You will discuss it in meiosis. Okay. That's how epithelia of seminiferous tubules looks like. This cell, I just try to point it out. So this cell, this is the nucleus of the cell, and this large cell, you see, it's a Sertoli cells. It's a carrying cell, so it maintains the normal maturation of responsible for spermatocytogenesis. Here we have the spermatogonia. Spermatogonia A and spermatogonia B, they are indistinctable, but they undergo the process of mitotic division, only mitotic division. So, and then finally after the mitotic division, we have a primary spermatocyte. So, and here I want to pay attention to this structure, number 4. It's a tight junction. It's a tight junction, it's a connection between the Sertoli cells. That's all the Sertoli cells are combined with the help of this tight junction. So here we see tight junction. And actually this junction prevents the passive passage of any material through the basement membrane toward the apical compartment of this epithelia. So nothing can pass here. It has a very important role because here primary spermatocyte actually undergoes the meiotic division, and in the end we have haploid cell generation. And this haploid cell generation, it has a different genetics than all other cells. Yeah, well, you remember this crossing over takes place. Of course genes and antigens will be different. That by this the junctions preventing the autoimmune aggression against cells. And maybe you remember in childhood they said to you, yeah, avoid injury to the testes. Boys will remember it. Avoid injury to the testes. Because if we injure the testes, first of all, the stage junction can be destroyed, and autoimmune aggression can reach this apical compartment of seminiferous tubules. And due to this, we have autoimmune antibodies. For that, we have a MAR test, MAR test. And this MAR test is actually showing that we have autoimmune aggression against our own sperm cells, and it might lead to the male infertility. So, and later secondary spermatocytes, which is invisible in histological preparation, usually forming the spermatids, and the spermatids undergoing the process of spermiogenesis, which is also carried by Sertoli cells. And the spermatids, so converting this casual cell, yeah, with the casual nucleus, casual cytoplasma cell, into the sperm cell. How it goes, we'll discuss a little further. So this is spermiogenesis. These features we have: it's a nuclear condensation, acrosome formation, flagellum formation, and cytoplasma reduction. Let's see what's going on here. Okay, a nucleus is a very large structure. After the cell division, it contains decondensed chromosomes, decondensed decondensed chromatid. Sorry. So this genetic material is decondensed, and there are a lot of water in between. There are a lot of nucleoplasm there. Yeah, and of course we need to reduce its size because sperm cell is one of the smallest cells of the human body, and they should be very mobile. They should be very very rapid. Yeah, so to reach the ovum. So that's why it plays very important role to condense this nucleus. And you see, from this large structure we form the very condensed nucleus. It's the first process. Second process is the formation of acrosomal cap. Acrosome, so just in few words, acrosome, it's like lysosome. It contains proteolytic enzymes, but they are specifically destroying the zona pellucida. So they are assisting in the penetration of the sperm into the ovum. So they are inevitable things which are responsible for penetration of the ovum. So without acrosome, penetration into the ovum, fertilization is impossible. So, and the Golgi apparatus, you remember the sex and containers, so they will form entire Golgi apparatus. They will form the special acrosomal cap, this yellow colored on this diagram. And finally, in natural sperm cell, it covers all the head of the sperm. The next process is the formation of flagella. Yeah. So this is flagella. So you remember it's a centriole, distal and proximal centriole, and out of this, out of centriole arising the flagella. So this flagellar structure. So that's we discussed in the first classes. So what is a flagella? So by structure, it's kind of similar to the cilia, but very enlarged, and they are growing toward this. This is this process of flagellar formation. Also, don't forget about cytoplasm. So if we reduce the size of nucleus, we have to reduce the size of cytoplasm also, because it's also extra weight for the sperm cell. So that's why we need to reduce it as maximum as possible. And here we see the minimal cytoplasm around the nucleus. So you see, compare size of this cell and size of this cell. So that's why by mass this cell is reduced many times. And also let's take a look at mitochondria. Mitochondria here were dispersed all over the cytoplasm, but gradually it's concentrated around the tail, forming the meat piece. So this is meat piece with the mitochondria. Okay, and now you see the structure of the mature sperm cell. This is the structure of mature sperm cell. It's a head, neck, so with the distal centriole, proximal centriole is present nearby. It will be useful for us after the fertilization. The centriole will take place in formation of zygote. But distal centriole, so it is used for anchoring the flagella. This flagella, which making this circular movements, which allow the sperm to move towards the ovum. And mitochondria, which is arranged here nearby, they're responsible for formation of energy. Energy will give the opportunity to the sperm cell to move this flagella. So this is this structure of sperm cell. Again, structure: head with acrosome on the tip with the proteolytic enzymes, nucleus, very condensed nucleus with very condensed chromatid, heterochromatin. Yeah. Then here we have a proximal centriole, distal centriole, and flagella arise from it. And flagella on this department is named as a meat piece. It's named as meat piece because it's a little thicker than a tail, and this meat piece contains a lot of mitochondria, and they facilitate the energy to the flagella. And finally we have a principal piece. It's a major part of the tail. And finally end piece. So end piece is not very motile, but it's additional helper in into one directional movement of the sperm cell. Genetic primordium, the following process take place. A wave of proliferation begins that lasts from the 15th week of the 7th month. Okay, it's Oogenesis, yeah. Okay, let's talk about oogenesis. Structure of the ovum. So here it's skipped, sorry. Structure of the ovum, it has a cortical cortex part of the ovary and medulla. Cortex of so we will concentrate our attention on the cortex of ovary. It contains so-named follicles. So how and these follicles can be divided into different stages. As it's written here, you see it's a primordial follicle, primary follicle, secondary follicle, tertiary follicle, and antrum follicle, or will be named as Graafian follicle. Finally, we have a Graafian follicle, which is not marked in this diagram. Okay. Sex hormones influence the primordial follicles to grow and restructuring to take place. From the primordial follicles, the primary follicles, secondary follicles, and tertiary follicles develop in turn. Okay, I'm to skip it. So one thing I have to confirm. Don't confuse primary oocyte and primary follicle. So you see, primary follicle is a structure of oocyte plus follicular cells around. That's a major thing you have to remember. Primary follicle, it's primary oocyte and follicular cells around it. So these follicular cells, they are attached to the surface of this oocyte and producing special hormone-like compounds which prevent the first meiotic division. Again, all the primary oocytes were deposited in the ovaries before the birth, all of them. And they are resting in a phase so named as a dictyotene, actually somewhere between zygotene and diplotene. So in this phase, this oocyte is resting and waiting for its turn. So it already started the process of oogenesis, but interrupted with the help of follicular cells. They preventing it. But when we have a stimulation by FSH, follicular stimulation hormone, So some of these follicles, they stop production of these chemicals which interrupt it, and they also cause a growth of these follicular cells. And here we see this primary follicle, follicular cells of primary follicle, they are raised up, they get enlarged. Oocyte remains the same. Yeah, here oocyte and here same primary oocyte is present, but follicular cells are getting larger, and this follicular epithelia is enlarging. Secondary follicle. In a secondary follicle, so this under the influence of FSH, follicular stimulation hormone, these epithelial cells getting larger and larger. They increase their size and also forming the multiple layers of the cells. And oocyte remains the same. Yeah, but I want to pay your attention to this structure. It's a zona pellucida. Zona pellucida, it's a very tough structure. It's a very tough connective tissue-like structure, so which contains a lot of fibers, which prevent the influence of these follicular cells on this oocyte. I remind you again, these follicular cells producing special chemicals, hormones, which prevent the meiotic division. But if we have very thick zona pellucida, these chemicals are not reaching the oocyte, and which stop preventing the primary oocyte to secondary oocyte division, first meiosis. Yeah, and then first meiosis is initiated when zona pellucida is formed. Okay. Around the cells, so these follicular cells or follicular cells which were multiplied, in most of books it will be named as stratum granulosum or granulosa cells. These granulosa cells are responsible for endocrine hormone secretion, and hormone is estrogen. They form the estrogen, and then around we have the theca follicular cells, theca cells, or theca externe cells, so which are also transforming into for the synthesis of estrogen for the female. So that's why hormonal cycle of hormonal part of menstrual cycle is determined by these hormones, by the structures. Tertiary follicle. Now let's show you tertiary follicle. So then it's tertiary follicle. It's when this multi-layered epithelial cells, so between the cells are formed cavity. So the cells producing liquid, and this liquid is fused together, forming something like a lake, yeah, between the cells, and this is named as an antrum. It's an antrum. It will assist in a further flexion of this ovum into the fallopian tube. So that's a structure. And here we see same granulosa cells are present around, same zona pellucida, same oocyte, but follicle is growing. Yeah, and parts of this follicle, for example, theca interne cells, are also growing, and around also organizes the theca externa. So theca externa, so which will play a role in the formation of hormones. Okay, so that's, you will read it. What is a graphene follicle? Sorry, picture were not depicted here. So graphene follicle actually is a similar structure with a very small cumulus oophorus. So this structure is named cumulus oophorus. It's an ovum. Actually, it's secondary oocyte, which already finished the first meiotic division, and zona pellucida, and granulosa cells, which are oriented around. So an antrum is expanding, so it's very large antrum. So when actually graphene follicle is visible with the naked eyes, and also we can see it in ultrasonography. It might reach the size of a few millimeters, 6, 7, 8 millimeters, and actually reaching 1 centimeter. So you can see it physically. And but mainly it's composed of the antrum, so because composed of this fluid. And what happening with this. Here we see. So what's happening with the follicle? So this is primary follicle, secondary follicle, tertiary follicle, so with the antrum, then finally Graafian follicle, so it's very large, and then outpoaching of the secondary oocyte with zona pellucida and with the follicular cells going on, and expulsion of these oocyte into the fallopian tube happening. So, and this process is named as ovulation. This is ovulation period. So here we have a hormonal level, so that's we're going to discuss in fertilization process. It will discuss in the next lecture. So also we have a phases of maturation. So this is first phase. It's lasting for 14 days. It's a follicular phase. Then we have a luteal phase. So what does it mean? So this Graafian follicle, sorry, let's turn back. This Graafian follicle, after the expulsion of the ovum, so the cells are remained, after the expulsion. So must be the cells undergoing the process of luteinization with the help of luteinizing hormone. The cells converting into the progesterone secreting cells, and they form the so known as corpus luteum. Corpus luteum, which is responsible for formation of progesterone again. And if fertilization happens, these cells are gradually increasing their size and producing more progesterone. If fertilization does not happen, these cells of Graafian follicle, which is named as luteal cells, gradually atrophied. They undergo the apoptosis, and that's why progesterone level decreases. Then menstruation happens, and then we have a corpus albicans. So that will be discussed in fertilization process. Okay, thank you for attention, and see you in the next lecture.